go. All right, so section 9.7 and 9.8, which we'll be doing next week on Wednesday, focuses on now applying the rules of integers to order of operations and to simplifying an expression. So next week we'll get into the combining like terms, the distributive property, and all that good stuff. So we're laying the foundation for everything associated with algebra. We're laying the foundation for everything associated with algebra. So just to give you an overall view of how a placement test for college works, most college placement tests are in 3 parts. One part is arithmetic. Can you do basic adding, subtracting, multiplying, dividing, along with percentages, proportions, things of that nature. One part is algebra, like pretty much basic algebra, the things you would have learned in Algebra 1 in the very beginning of Algebra 2. The third part is the advanced algebra concepts. So that's where your factoring, quadratic formula, exponent rules, that's where a lot of those things are. You don't really see a lot of trig on a college placement test. You don't really see a lot of geometry on a college placement test. I mean, they'll talk about find the missing angle in a triangle, or find the perimeter, or find the area, but you don't see proofs, you don't see some of those in-depth concepts of geometry. Over the course of the semester, we will take 3 practice college placement tests so that you can see what's asked, how the question's formatted, what would be a decent score, so on and so forth. So I know one of them will be next week. So there's ways to get you prepared as you prepare to transition on about it. Nonetheless, so the first page of the notes page today is simply a cheat sheet about integers. It reminds you what is an integer, how you find the absolute value, and then how do you add, subtract, multiply, and divide integers. So this is a one-page cute cheat sheet type thing for those people who need the reference of how to do each of the 4 types. So that's there. Use it for those of you who may need to use it. But that's there for you. Our focus is going to be on order of operations. Yes, order of operations keeps showing up. It's going to keep showing up because it exists. So there's no other real way around it. The order of operations is still the same. Parentheses, exponents, multiply, divide, add, subtract. Again, multiplying and dividing, it's whichever comes first. Adding and subtracting, it's whichever comes first. So subtraction comes first before the adding. You got to do the subtraction first. If division comes before the multiplication, you have to do the division first. The order of operations still applies. So we're going to do a few basic examples, follow that up with a few examples in which it's going to make you think a little bit. All right, so example 1. Start off with some basic problems. We've got negative 24 minus 9 times negative 2. So we're following the order of operations. What's going to get done first? If we're following the order of operations, what is going to get done first? So we're going to multiply right there. So take the sign that's in front of the 9. So -9 times -2. So you get positive 18. Then what? What does that give you? And then you get -6. So a negative plus a positive means you subtract the two numbers and take the sign from the bigger number. That's it, problem's over. So let's do example 2. So 3x squared plus 4x when x is equal to -4. So before we try to solve the problem, what has to happen first? So before I solve this problem, what am I doing first? So wherever you see x, you plug in -4. That's 3 times -4 squared plus 4 times -4. Yeah, I do have interference in my board, so apologize if it looks funny. All right, so if we're following the order of operations, what comes first? We have our parentheses, then the exponent. So -4 squared gets multiplied first, and will get solved out first. So -4 squared is what? 16. So for those of you who are using the calculator, make sure that you put the -4 in parentheses if you are using a calculator. If you're using a calculator, the negative has to go in the parentheses. If you don't put it in parentheses, you're going to get the wrong answer. So don't say I didn't warn you. But now we can go on. 3 times 16 and 4 times -4. So what would those two be? Feel free to use the chat to type in the value. You type in your response as well. But 3 times 16 and 4 times -4. -16, 48. 4 times -4, -16. So if we add those two up, what do we get? I heard 30. I didn't hear the end of it. Positive plus a negative. So again, when you're adding different signs, you subtract the numbers and take the sign from the bigger number. So it is 32. Any questions before we continue? Oh, appreciate that. I've seen your hearing aid, so let's go to example 3. So, what do you notice is in example 3? So, what do you notice is there that might give you difficulty if you were solving it out yourself? So you got brackets and parentheses. Brackets and parentheses, so that means start from inside. Well, make this easier for myself to write. Work from the inside out. Work from the inside out. So you got bracket and parentheses, so we're going to work from the inside out. So, negative 11 plus 7 cubed divided by negative 2. So, negative 11 plus 7 gives us what? 4. Positive 4 or negative 4? So I agree with the 4, but is it positive or negative? Negative 4 to the third divided by negative 2. So we have exponents in division. So exponents goes next. So negative 4 to the third power negative 4 to the third is negative 4 times negative 4 times negative 4. So what value is that? That's going to equal something. Drag your feet with it. Cue up my Jeopardy music in a second. I'm assuming this answer must be negative 12. That's what I think it is. It's probably negative 12. It's definitely negative 64. Definitely negative 64. Negative 4 times negative 4, positive 16. 16 times negative 4, negative 64. So we're still going to finish the bracket off. Negative 64 divided by negative 2. A negative divided by a negative is positive. What's 64 divided by 2? So that's 32. 32 minus 6, 26. You don't need the bracket if there's only one number in there. I mean, if you kept it, it doesn't change anything, but once you get down to one number, you can get rid of it. Any questions before we move forward? This time I'll give you all some time to start. All right, so let me grab my stopwatch and give you a little bit of time to start the problem. Look at this together. All right, so if we are solving this problem, where do we start? Or where did you start? Top of the fraction. Continue. So the top part is taken care of. Somebody else, what did we do? What do we get for the bottom part? How does the bottom part work out? Top and the bottom taken care of. So that means we have negative 6 divided by 6, which is negative 1. So this is a good way to solve the problem if you have it set up as a fraction. Work out the top, work out the bottom, and then divide the two ends. That's a good way to think about doing it. Any questions, example 4? All right, examples 5 and 6. So we're going to translate the sentence into an algebraic expression and then evaluate it when x equals negative 3. So they're kind of telling you what variable to use. They want you to use x to convert this into an algebraic statement. So 4 less than 5 times a number. 4 less than 5 times a number. 4 less than 5 times a number. 5x minus 4. Absolutely right. So 4 means 4. Less than means minus. 5 times a number. But Steve remembered that less than means you have to switch it around. So 5x minus 4. So that's your expression. Any questions on how we got the expression? So again, Steve, good job. Now, you plug in -3. Take -3, plug it in right. Now it becomes a solve it out problem. So now what do we get? Now what do we get? We've done algebra skills. I haven't heard too many from females in this class. Where are they at? No. 5 times -3 minus 4. What do we get? -19. 5 times -3, -15. -15 minus 4. That's the keep, change, which gets you -19. Keep, change belongs to subtraction, which that is indicating subtraction. So the 4 itself would be negative if the 4 was attached to something else. Excellent observation. All right. Let's look at problem 6, and then we'll have time to look at the last example that we'll do today. So example 6, translate to an algebraic expression and then evaluate when y is equal to -2. So, case in point, they want us to use the y variable. So take a moment to think about it. I'm going to underline the key parts. All right. What's somebody's hypothesis? This one's a little bit of a trickier one. It doesn't mean we run away from it. If it's wrong, then we'll fix it. So 3 times a number, so 3y. So 4x means 4 times x. Think about what they're asking you for. of the 4 plus y. All right. So let's look at a problem like this. Because this is a problem that I pulled off of SIU's college placement test. So the quotient. Quotient means you're dividing. So you're going to be dividing something. You're dividing two different things. Of 3 times a number. So 3 times a number. So that's 3y. And the sum of a number in 4. Sum means adding. A number, y, 4 is 4. So that's 3y divided by y plus 4, or 3y over y plus 4. So either way would work, but know that that's how the problem is interpreted. Any questions? Example 6. We're not done though, because we still got to deal with the negative 2. Now remember, writing expressions was done in section 9.2. So something like this could show up on your quiz. All right, let's solve it out. So there's your expression. I told you that y is equal to negative 2. So take negative 2 and plug it in. Three times negative 2. What's that? What's 3 times negative 2? At the top, negative 2 plus 4 gives you what? Positive 2. So now we can add our answers up. Negative 3. Any questions? Example 6. Again, make sure, ladies and gentlemen, that we finish strong. We got 4 months left, and you walking across the stage and moving on to the next stage of your life. Don't let senioritis get you. All right, so last example. So problem number 7. We've got 3 students, Nia, Christian, and Elise. So these 3 students are solving that problem. 7 minus 4, parentheses, 3 minus 8 squared. 3 students solved that problem. Look at how they solved it and tell me who did it wrong. So take a moment and look at it and tell me who did this problem wrong. Pause my recorder so you can have. So all 3 of these problems are wrong. And Jordan did call it. He did say that all 3 of these were wrong. So here's why they're wrong. So Nia's problem, she started off right. 3 minus 8 is negative 5. But negative 5 squared is not negative 25. It's positive 25. So that's where her mistake is. And then everything else would have been wrong after. Christian's problem. He started off violating the order of operations. He did 7 minus 4 and put 3. That violates the order of operations. So in Elisa's case, 3 minus 8, negative 5. Good. But here's where this young scholar violated the order of operations. You're supposed to do exponents before multiplication. So that's where that violation came from. So yes, all three versions are wrong. And Derek, like you said, like you had asked about playing with your head, I'm not playing with your head. This is how I've noticed you all get the problems wrong. So now I get to show you why they're wrong. So if we solved it correctly, 3 minus 8 is negative 5. Negative 5 squared is positive 25. Negative 4 times 25 will give you negative 100. And 7 minus 100 is negative 93. That's the correct answer to the problem. That's the correct way to do the problem. Any questions? Example 7 before we close up shop.